Good morning, students. So today we are going to discuss about compound microscope. Okay. So this is also one of the optical instruments, isn't it? So it is the compound microscope. Okay. Now in simple microscope, what we have got, it was consisting of a single magnifying lens, isn't it, or single convex lens. Okay, but this compound microscope, it is consisting of two converging lenses. Okay, so one having a smaller aperture and smaller focal length. Okay, and second having larger aperture and also having focal length that is moderate. Now it is greater than this first lens. Okay, now the first lens, which is having smaller focal length and smaller aperture, it is placed near the object, okay, which is known as objective lens. Okay, and the second lens having larger aperture and also having focal length that is greater than this objective lens. Okay, so it is placed near the eye to observe, okay, the magnified image of the object. Okay, so the lens which is placed near the eye with larger aperture and larger focal length, okay, that is known as eyepiece lens. Okay, O, it is objective lens. Okay, and E for eyepiece lens. Fine. Again, both the lenses, they are placed or separated from each other with a suitable distance. Okay, or we can also adjust the separation between the two lenses, okay, by rack and pinion arrangement. Okay, now here you see, since it is consisting of two lenses, fine, so we can get the magnification of the compound microscope due to both the lenses. Okay, so here we'll get total magnification, that will be magnification due to objective lens, and that will be linear magnification, okay, multiplied by the angular magnification of the eyepiece lens. Okay, so here we'll get total magnification, okay, which will be the magnification due to objective lens and magnification due to eyepiece lens. Okay, okay, so we'll get total magnification due to both the lenses. Okay, now for image formation, here you see final image will be formed by eyepiece lens, isn't it? Okay, because here first object we have to place in front of objective lens, then after refraction here we'll get one image only due to objective. Okay, and that will behave like virtual object for the eyepiece lens. Okay, and due to that virtual object, so we can get the final magnified image due to this eyepiece lens. Okay, now for image formation, so here we can consider two position, isn't it? So one, it is at a distance of minimum distinct vision, that is 25 centimeter. Okay, and second position that will be at infinity. Fine. Now first, if we consider when the final image will form at a minimum distance of distinct vision, that is D, now which is 25 centimeter. Okay, so when the final image, it will form at a minimum distance of distinct vision. Okay, then your image formation, it will be like this. So here this is the objective lens with small aperture. Okay, that is placed coaxially along with the eyepiece lens. Fine. Now object, it is placed in front of the objective lens. So here we have considered one object. Suppose it is AB. Okay. Now this is the object with height h, and if we take one ray that is parallel to principal axis. Okay. Second ray which is passing through the optical center. Then you see the ray which is passing through the optical center of objective lens. Okay, so this will move without deviation. है नहीं? ठीक है? तो ये रे हमको सेम डायरेक्शन में ही मिलेगा ना, without deviation. And the second ray which is parallel to principal axis, after refraction what will happen? It will pass through the focus, isn't it? तो हमको ये रे इससे मिलेगा. Okay. Now both refracted ray they will intersect at a single point, isn't it? After refraction from the objective lens. Okay. So here first image will form due to objective lens. This is A dash, B dash, and this will behave like virtual object. Okay, मतलब objective lens का जो image है, that is A dash, B dash, now it will behave like a virtual object for the eyepiece lens. Okay, so now here this is the eyepiece lens which is having larger aperture and also having larger focal length, isn't it? Than the objective lens. So this is the eyepiece lens. Okay. Now these two refracted rays, after refraction from the objective lens, they will further incident on the eyepiece, isn't it? Okay. Like this. And final image, we can get at 25 centimeter, isn't it, from the eyepiece lens. Okay. So हमको जो final image मिलेगा, so it will form at distance, that will be 25 सेंटीमीटर. मतलब यहाँ पे देखो ये दोनों जो इंसिडेंट रे है ना फॉर आईपीस लेंस, so they will move in this direction, isn't it, after refraction. That means now they will diverge so that final image it will form at minimum distance of distinct vision. Okay. So now for these two diverging refracted rays from eyepiece. Okay. So here we observe the image, and final image will form at a distance of d, that is minimum distance of distinct vision. Suppose ये final image है a double dash b dash dash, ठीक है, which will form at distance of 25 centimeter from the eyepiece lens. Fine. So for the image when it will form at minimum distance of distinct vision, okay, then your ray diagram, isn't it, for image formation will be like this. Fine. Okay. Now here you see for this objective lens, isn't it, so we will get linear magnification. Okay. So here objective lens के लिए this is the object distance, isn't it, for objective lens. Okay. And from optical center of objective lens to B dash. Okay. ये जो distance है ना from optical center of objective lens to B dash, isn't it? So ये distance कौन सा हो जाएगा? This is image distance due to objective lens. Okay, ठीक है? And here from optical center of eyepiece lens, okay, to B dash. So here you see this A dash B dash. Now this will behave like a virtual object for eyepiece, isn't it? So this will be the object distance for eyepiece lens. Okay, ठीक है? तो अगर तुम लोगों को ये फिगर में कुछ डाउट है ना, तो तुम इसको तुम लोग क्लियर कर लो, ठीक है? पहले और एक बार देख लो. यहाँ पे ए बी जो है that is the object, okay, which is placed in front of the objective lens. Fine. Then for this object we are getting the image A dash B dash due to this objective lens. Okay. And this image A dash B dash of objective lens, now this will behave like a virtual object, isn't it, for the eyepiece lens. Okay, so after again after refraction from the eyepiece lens, the final rays will diverge. Okay, so because of that we are getting a magnified, okay, image, now final image at a distance of 25 centimeter from eyepiece lens. Clear? Now here you see the total magnification of this compound microscope due to image formation at minimum distance of distinct vision. ओके, तो इसके लिए हमको मैग्निफिकेशन कितना मिलेगा? दिस विल बी total magnification will be what we have got, that is linear magnification of the objective lens, okay, multiplied by angular magnification due to eyepiece lens. Okay, and you say for ऑब्जेक्टिव लेंस ना, जो हमको मैग्निफिकेशन का फॉर्मूला मिलेगा लीनियर मैग्निफिकेशन का, क्या हो जाएगा? दिस इज वी नॉट बाय यू नॉट, इजंट इट? ठीक है, इमेज डिस्टेंस ऑफ ऑब्जेक्टिव लेंस divided by object distance of objective lens multiplied by, now you see for this eyepiece lens, isn't it? तो हमको simple microscope में ना, तो near point image और far point image, मतलब at a distance of minimum distance of distinct vision, isn't it? And at infinity, तो दोनों केस के लिए ना हमको मैग्निफिकेशन ऑलरेडी मिल गया है कि नहीं? सो अभी हम लोग आई पीस के लिए ना डायरेक्टली वो रिलेशन को यूज कर सकता है. ठीक है, अभी तुम लोग इसको ऑब्जेक्टिव लेंस को तुम लोग इसको अभी कंसिडर मत करो. ठीक है, तो इसके लिए देखो, this eyepiece, it is forming an erect and magnified virtual image of A dash B dash, isn't it? So for distance of minimum distinct vision, isn't it? तो उसके लिए हमको मैग्निफिकेशन का फॉर्मूला क्या मिला था? क्या था? तो 1 प्लस डी बाई एफ, isn't it? यहाँ पे एफ मतलब अभी क्या हो जाएगा? आई पीस का फोकल लेंथ हो जाएगा. ठीक है, ओके. सो फॉर आई पीस दिस विल बी 1 प्लस डी बाई एफ ई. ठीक है, तो एफ ही मतलब focal length of eyepiece lens. So we'll get finally the total magnification due to image formation at minimum distance of distinct vision. This will be equal to image distance of the objective lens divided by object distance of objective lens, okay, into 1 plus d by f e. Clear? So this will give the total magnification by the compound microscope when final image will form at minimum distance of distinct vision. Okay, here V naught, it is the V naught, यहाँ पे क्या हो जाएगा? This is image distance, okay, of objective lens, okay, u naught object distance of objective lens, okay, and d it is, this we already got 25 centimeter, fe focal length of eyepiece lens, okay. Now if we consider the second position, okay, the second position means क्या हो जाएगा, when the final image will form at infinity, okay. So when final image will form at infinity, isn't it, at infinite distance from the eyepiece lens, okay, then your image formation, isn't it, तो ये हमको अभी इसका रेट रहेगा, हमको कैसा मिलेगा, that means now here this is the objective lens, okay, object placed in front of the objective lens, सेम है ना, इमेज का हम लोग फॉर्मेशन जैसे कि फर्स्ट केस में हम लोग किया था ना, सिमिलरली कंसिडर करेगा. तो हियर यू टेक वन रे दैट इज पैरेलल टू प्रिंसिपल एक्सिस, ठीक है. आफ्टर रिफ्रैक्शन it will pass through the focus, isn't it? Then second incident ray which will pass through the optical center of the objective lens. So after refraction, these two refracted rays, they will intersect at this point, isn't it? So here this will be the image of the क्या हो जाएगा objective lens, that is A dash B dash. Okay. Now these two refracted rays, they will again incident on the eyepiece lens, isn't it? Okay, so this is the eyepiece lens, and now after refraction from the eyepiece lens, so these two rays, they will become parallel, isn't it? So their final image will form at infinity. Okay, now these two refracted rays, after refraction from eyepiece lens, so they will become parallel, isn't it? Okay, so that final image will form at infinity, like this. Okay, so here if we observe the image, then it seems that it will form at infinity. Okay, so in this case, isn't it, अभी देखो इसका तो linear magnification same होगा ना, this is V naught, isn't it, image distance of the objective lens, and this is object distance of the objective lens. ओके अब इस सेकेंड लेंस के लिए देखो आई पीस के लिए जिसका हमको सिंपल माइक्रोस्कोप में मिला था ना, व्हेन फाइनल इमेज विल फॉर्म एट इंफिनिटी, ठीक है, ओके, देन मैग्निफिकेशन विल बी क्या हो जाएगा, देन विल गेट टोटल magnification of the compound microscope. So it is magnification due to objective lens, okay, it is linear magnification, and angular magnification due to eyepiece lens, isn't it, when final image will form at infinity. Okay, so this we have got V naught by U naught into, ये अभी क्या हो जाएगा, ये हमको सिंपल माइक्रोस्कोप में मिला था ना, जब इमेज फाइनली इनफाइनाइट पोजीशन में फॉर्म होगा, दैट इज डी बाई एफ ई, ठीक है. सो दिस विल गिव द टोटल मैग्निफिकेशन इन केस ऑफ compound microscope, okay, when final image will form at infinity. Okay, so similarly here U naught means object distance for the objective lens, V naught image distance for the objective lens, D क्या है 25 centimeter, FE focal length of the eyepiece lens. Okay, now here from the optical center of eyepiece lens to B dash, isn't it? तो ये क्या हो जाएगा? This is the object distance due to eyepiece lens. Okay, ठीक है? So ये था कंपाउंड माइक्रोस्कोप, ठीक है. तो इसके बाद हम लोग डिस्कस करना है अबाउट टेलीस्कोप. ओके.